If you take a monomer like lactic acid with the IUPAC name 2-hydroxypropanoic acid, this has a hydroxyl functional group on one end and a carboxyl functional group on the other end. You polymerize them by getting rid of these bits to form this and joining them here like so, continuously, and you get polylactic acid, PLA. Because this polymer is joined by an ester link, it's known as a polyester. This is the abbreviated form of the repeating unit. Polyesters can also be formed from two different monomers, for example, ethylene glycol, aka ethane 1,2-diol, and terephthalic acid, aka benzene 1,4-dicarboxylic acid. This has two hydroxyl functional groups and this has two carboxyl functional groups. When they join, these come off and form water, and then these form your polymer like so. This is known as polyethylene terephthalate, aka PET. This is the abbreviated form of the repeating unit. Because both examples release a small molecule as a byproduct when they polymerize, like water or methanol, they are known as condensation polymers. So when monomers have these as a functional group, they're suitable for condensation polymerization. Nylon 6 is another example of a condensation polymer. 6-aminohexanoic acid has an amine functional group here and a carboxyl functional group here. When these monomers join, these come off to form water. The carboxylic part comes off one end and joins with the amino end of the other monomer continuously. This is the abbreviated form of the repeating unit. Because the polymer is joined by an amide link, it is known as a polyamide. Polyamides can also be formed from two different monomers as long as the functional groups are aligned in a way that the amine group of one monomer is next to the carboxyl group of the other monomer. So in the case of nylon 6,6, hexamethylene diamine, aka 1,6-diaminohexane, joins with adipic acid, aka hexandioic acid. These come off to form water, and these join here, and so on. This is the abbreviated form.